Hi everybody, welcome to Sunya IAS. Welcome to the mains crash course for GS3. Today we're going to talk about the first lecture of GS3 environment, that is going to be climate change. Now in climate change, it's a very interesting topic, it's a very interlinked topic. So firstly, I'll tell you what is the roadmap, what are we going to cover. So here, basically we'll see first of all the very basic, what is climate change, okay? And then from the mains perspective, we'll just see basic definitions. What is global warming? What is climate change? Then we should know certain facts related to it. Okay. And by facts, we mean what are the evidences to support climate change is happening. Then we go into what are the causes, okay, of climate change. So whenever we do the causes, as much as possible, we'll try to bifurcate it further into natural, okay, as well as man-made, anthropogenic. So we'll see that. Then a very interesting part, this is going to be what is the impact of climate change, and after that what are the consequences of climate change, right? Now here this is going to be an important part, so that if you understand this well, and here we'll try to have very simple dimensions throughout the world, throughout the globe, the various ecosystems that we see. Okay, so here all you have to do is to then just write it once or twice, and we'll try to do this very organically so that the points you can derive automatically, right? So when you do this impact, and then on based on the impact, what is the consequence? For example, what is the social consequence? What is the political consequence? Economic consequence? Okay, so for example, if the sea level is rising, what is the political consequence? The people will move out, there will be migration, there will be crisis. Okay, so this is going to be a very important part. And whenever we understand this, always understand two types of questions that can be formed here. Okay, one can be India specific, and one can be at the global level, right? So here what we can do to differentiate our answers is to first of all know the basic dimensions, okay, and then we can tailor make it. We can have India based examples to make it with respect to India, similarly global examples. Okay, so when you are done with this basic framework, and this you can use throughout, okay, so this is one. And then we move to a very interesting part, is current affairs updates and developments. Okay, so here we will see very important part. For example, why was 2023 the warmest year ever? Okay, this itself can be a main question that can be asked to you. Similarly, we'll see more specific ecosystem updates. For example, what is Arctic amplification? Okay, why is it happening? What will be the consequences? Because of late, earlier what used to happen, UPSC used to ask you general questions. Okay, for example, what is pollution? Now they're asking you more specific, what is ozone pollution, what is oil pollution. In the similar manner, while you can expect a broad question on consequences, etc. of climate change, but you can also expect some specific questions. So you should be prepared about it. Okay. Then, for example, we'll see, for example, what is Karakoram anomaly. And lastly, we will also see and talk about what is going to be carbon inequality. Okay, this will ultimately form the base of the next lectures. It is the carbon inequality, the wedge between the developed and the developing world, which is going to cause all the problems. So this is also going to be a very important topic, carbon inequality. Okay, so this is going to be our roadmap for this lecture. All right, and we will begin, right? So we'll talk about what is climate change, a very basic framework for us to understand, right? What is climate change? Okay, what are the evidences or the facts to support what is climate change? What are the causes? Natural causes, man-made causes. What are the impacts? Okay, and of course, based on the impacts, what will be the consequences? Then when you extend this further, we talk about initiatives taken by India related to climate change, initiatives at the global level to fight climate change. And in doing that, right, then we will see the burning topic of COP28, and we will analyze it very holistically from the mains perspective. So when you do climate change, any of this, if you have this basic roadmap and the basic mind map of what all is to be covered, okay, so for each section you should have certain content available with you. If you have this, ultimately this is what is needed. Okay, this is there. Now a couple of things extra, because when we're talking of climate change, there are few things I want you to always remember. Okay, see, climate change is going to be a very much interrelated topic. Okay, so even before starting, I will tell you it has a lot of interlinkages. So when I write SDG means Sustainable Development Goal, right from SDG 1, which talks about poverty, SDG 2, hunger. These are all directly related to climate change. So when we move into the aspects of impacts and the consequences, we will again see this being directly impacted. Okay, I'm also writing some notable SDGs, but you can even add further ones. Not okay. For example, gender equality, SDG 5. 7 is related to energy, again directly related to climate change. 13 being itself related to climate change. Okay, 14 will be life below land, which basically 14 talks about water, and 15 talks about life on land. So basically land degradation, desertification, we talk about in this manner. Okay, so first of all, if this, I'm in the very basic starting, I'm telling you that you will have to understand that yes, climate change is impacting social outcomes, poverty, hunger. We will link this a bit later on to agriculture as well, how this is impacting. Similarly to women, so again think of vulnerable sections. Climate change, again very much important. Linkage, energy, very important, the access to energy, and that is why we talk about things like carbon inequality. So when you understand this very basic framework, things will start to make sense to you. Okay, so SDG linkage is one thing I'm just mentioning at the outset. Again and again when we encounter these topics, for example, when I talk about land or when I talk about oceans, think about climate change and you can directly correlate. Okay, so these are very basic things I'll tell you. Okay, now with respect to what is climate change, okay, so there are two things that one needs to be just basically be aware about. These are very basic definitions. Okay, so number one, for example, there is a term known as global warming and there is a term known as climate change. Two terms, global warming and climate change, right? So we'll just try to remember what these are, very basic definitions. Okay, what is global warming? So global warming is going to talk about, or is going to be only related to increase in temperature. Okay, this is the average increase in the temperature which the earth is seeing. Okay, that is global warming. Why is global warming happening? Because of increase of greenhouse gases. Now in prelims we have already known that greenhouse gases are both natural, for example water vapor being the largest greenhouse gas, and greenhouse gases can also be man-made. Now the problematic part is that man-made greenhouse gases are increasing very much. How? Or same in different sectors, be it burning of fossil fuels, industries, vehicles, construction, all these sectors. So ultimately a lot of industrialization has led to increase in the greenhouse gases, man-made gases. Okay, and there were already natural greenhouse gases as well, like water vapor. This you cannot do much about, but this is the problematic part. Okay, the man-made greenhouses gas, they are increasing. What this is leading to? It is leading to creation of a blanket. Okay, a blanketing effect is created by the greenhouse gases known as the greenhouse effect. What does this lead to? This leads to increase in temperature of the earth. Okay, so there is increase in temperature of the earth which is referred to as global warming. Okay, and again as the lecture moves on, you will see every year after year we are seeing that this year is the warmest year. Fine, so why is this happening? Increase in man-made gases, man-made greenhouse gases like Okay, why is that increasing? This also we have seen. Okay, agriculture, all these activities promoting to increasing greenhouse gases. Fine. So again, what is global warming? It is the average increase in the temperature of the earth. Okay, whereas climate change is going to be more holistic. Okay, so not only does it talk about the impacts of increasing temperature, it also talks about altered weather patterns. Okay, long term changes, and long term changes in basically precipitation. Okay, extreme weather events. Okay, all of this ultimately is going to be defined what is climate change. Okay, extreme weather events. Okay, so again, please remember, climate change is not limited to only the increase in temperature. That, of course, is signified by global warming. But climate change is much beyond that. That it talks about changes in the formation of clouds, changes in the formation or movement of winds, okay, altered weather patterns, even the extreme weather events, the frequency and the intensity of extreme weather events, all of that total overall combined, that long term effect is known as climate change. Okay, so this basic definition is something that we have to just understand. So till now, what I have told you, that number one, there is a lot of interlinkages that we'll see throughout. Number one, SDG linkages. Then what is climate change? For that, you need to know what is global warming, what is climate change. Very basic definitions till now we have seen for ourselves. I hope this is clear. Okay. So when I say what, this is the what I was referring to. Okay. So that is why one by one, in a very structured manner, we are going to go through this. What, I hope this is clear. Same thing if you understand through a basic infographic. Okay. What is this? Global warming, gradual increase in the earth's surface temperature. That is just what we discussed. Increased greenhouse gas concentration is there. Okay. This will lead to formation of a layer. Okay. And this leads to again trapping of outgoing radiation. This is what greenhouse effect. Whereas climate change, climate change is the long term change in the global weather patterns. It is the long term change in the global weather patterns, like we saw formation of clouds, extreme weather events, okay, rainfall, precipitation, temperature, all of that. So not only it talks about temperature, but it talks about various things. That is why climate change is very much holistic in its definition. Okay, so this is again the very first basic thing that we have seen. Now, suppose you get a question in your mains related to carbon dioxide, which again is a very probable topic. How should you use your basic knowledge of prelims? Okay. So again, remember, whenever, see, carbon dioxide is your prominent greenhouse gas. So so here, if you ever get a very basic question, let's say a 10 marker, you should one draw a simple diagram. Okay. There is an incoming solar radiation. There is outgoing solar radiation. It is getting trapped, and because it is getting trapped, this is leading to warming of temperature. Okay, so how can you draw a diagram? Whenever possible in mains, we'll also try to draw a diagram. Okay, this is sun, this is short wave incoming radiation, whereas here is an outgoing radiation as well. Okay, now this is getting trapped by a layer of, this is the blanket of greenhouse gases. This is the blanket of greenhouse gases which is trapping the outgoing radiation. Fine. This is what we remember. So, what are greenhouse gases then? Okay. So, again, I've told you, just remember these, they can be both natural as well as man-made. They lead to what? Something known as greenhouse effect. When we say man-made, what are the basic greenhouse gases? Let us quickly recap. You have carbon dioxide, you have methane, you have nitrous oxides, and you have fluorinated gases like hydrofluorocarbons, okay, perfluorocarbons, and sulfur hexachloride. Okay, Now, if you want to ask, let's say, which of the ones are more important, yes, of course, carbon dioxide will be very important, but your methane also will be very important this year. Okay, why this year? Because there have been references in COP28, Conference of Parties 28. You would have read about this in prelims. This happened in Dubai, and it spoke about reducing the non CO2 emissions like methane. So this was directly mentioned. Okay. So you can expect questions here. That is why just a very basic of what are greenhouse gases. Okay. So greenhouse gases are the ones which trap the outgoing terrestrial radiation. They let the incoming radiation. Okay. The incoming radiation is ultraviolet, outgoing radiation is infrared. So greenhouse gases, what they do, they trap the outgoing radiation, leading to increase in the temperature. Notice I'm again and again saying increase in temperature. Increase in temperature will also have a lot of impacts. That also will be understood in a very simple manner. Okay, that when the temperature increases, what all can happen. And here we are going to follow a very simple ecosystem based approach. Fine. I hope till here you are able to understand. So here again in main, see what you have to do. You have to be very much whatever is asked. Let's say if the question is basic, first of all, on greenhouse gases and their impact on the ecosystem. So you should be able to define greenhouse gases. That is why I've told you about the natural. The biggest component of natural greenhouse gases is water vapor. So please remember that. Whereas for man-made, we've already seen the biggest component is by carbon dioxide. Almost 70% is contributed by carbon dioxide, followed by methane, followed by nitrous oxide, followed by fluorinated gases. Okay, and what we know that it is the man-made gases. This is the problem. This is increasing, and that is why you have more pronounced greenhouse effect. Okay, this is at least the basic that I wanted to tell you. Okay, so a very simple diagram like this to understand difference between the two. I hope we are able to make some sense. Fine. So this is something that we have seen. Now, talking of evidences, right? So one, I am saying the man-made component of greenhouse gases is increasing. But okay, so how do we say that? Again, whenever we write data, it will always be better to mention the organization. Okay, so from now, whenever you would write about climate change, if possible, either quote IPCC or you can quote WMO. WMO is World Meteorological Organization, whereas IPCC is Intergovernmental Panel on Climate Change. So whenever you write, for example, in the introduction or in the body, any point related to climate change, if you write according to IPCC, according to WMO, this will add great weight to your answers. Okay, so that is something that you will keep in mind. Okay, now when I say facts related to climate change, what are they as an institution or through the reports, what are they wanting to convey? This is something that also we need to know. Okay, so we will see, and just only the things that are your takeaways. Okay, so I'll tell you 2 or 3 important facts for each what they're saying. Out of them, so first you should make your notes, you should write these facts down, but at the end at least 2 or 3 facts you should take away. Okay, that are the ones you should remember and write in your answers. Fine. So one, when we are saying that in this what is happening, number one is related to your greenhouse gas, that is carbon dioxide. Fine. Now this is again an area where you can easily draw a diagram. Okay, what you can do, what are we saying? See, when we are saying that carbon dioxide is increasing, we can show it through a diagram. Okay, what will the diagram say? Okay, so roughly you can even start from 1850s if possible. Okay, 1960s, and then of course 2024. So what is happening? The concentration of carbon dioxide is increasing very rapidly. Okay, now the safe level was somewhere around 350 ppm. Okay, safe level was somewhere around 350 ppm, but of course right now it has surpassed. So around 428 ppm carbon dioxide levels are here. This is again told by the IPCC report. Okay, why did I write 1850s? Because I wanted to tell you that post the industrial revolution, the level of greenhouse gas emissions is far higher. Okay, very high concentrations of greenhouse gas emissions post the industrial revolutions have happened, right? So this is the safe level, and we've far exceeded the safe level. This is why this is becoming problematic. So first takeaway for us is that the carbon dioxide, this is what is showing. They've started from 1960, so you can even start from here. Okay, and this is a very updated data, 31st May 2024. Fine. What does this tell you? That the safe level was 350. Right now you are at 427.8 ppm. ppm means parts per million. Again, this is just a unit metric. For example, if we have salt, if salt is present in water, it is measured in ppt, parts per thousand. This is parts per million. Fine. This also, first of all, this basic fact tells you, number one, greenhouse gases are increasing, and increasing at a very alarming rate. Okay, so the first thing for us is carbon dioxide concentration. They have surpassed 427 ppm, very alarming, as per IPCC's report, and even the WMO in its report will also tell you the same. WMO also monitors greenhouse gases. So generally, if the greenhouse gases are high, it will also give you the same thing. So one, this is going to be very alarming. First takeaway for us, okay, the exact point that we'll want to write is this. Fine. Next, we'll see a couple of more points. Same thing. I've told you, if you want to remember even one more gas, fine. But even if you remember only carbon dioxide, that is good enough. Okay. For carbon dioxide, this is again as per the data. So now they are mentioning as per 2022. I've given you even the data of 2024. Okay. That for, it is not even 419, it is 427. Okay. Almost 428. Okay. So this, I told you, the most recent figure is 428. But see the trend. We are more concerned about the trend. Trend is rapidly increasing. Okay, for carbon dioxide and even for the methane. Okay, methane, remember, was mentioned as non-carbon dioxide emission. The trend for methane is also increasing. Fine. So this is also there. So till now what we have seen, carbon dioxide, methane, they are rapidly increasing. What are both of them? Both of them are our greenhouse gases. Okay, this is also rapidly increasing. Now methane is measured in parts per billion. Okay, if you want to remember, it was I think 1902 or 1904. Okay, so two facts till now we have seen, but overall I can club both of them under that greenhouse gases are increasing. Okay, and I have exact proper fact as per a particular organization, IPCC. That is one thing I'll take away. Fine. Now moving on to other areas, again IPCC talks about four major things. Okay, now I will also quantify them one by one. For example, I've already quantified CO2 concentration. Carbon dioxide concentration is highest in at least 2 million years. Okay, this is something that we have seen. Okay, that this is very much increasing. Okay, now for each of them, please remember, now sea level rise. IPCC says that by 2100, sea level rise will be, or it will rise by 1 meter. There will be a 1 meter rise in the sea level. That is a huge rise. Okay, so overall the rates are fastest in at least 3000 years. Okay, so again this goes to show and tell us that this is going to be very much problematic. Okay, then Arctic sea ice area. Okay, this has been at the lowest level in almost 1000 of years. I can here give you example of Greenland ice sheet, which has reduced considerably in size. The Arctic sea ice area is receding, and here of course we will link our current affairs in the later part when we talk about a term known as Arctic amplification. Arctic amplification basically tells you that in the Arctic region, warming is almost twice the global average. Okay, so whatever warming is happening in other parts of the world, the warming happening in the Arctic is 2 times. Okay, why is that? We'll see in the coming slides. Okay, but here, for example, for everything we have facts now. Carbon dioxide concentration, they have surpassed 427 ppm. Sea level rise is projected to be 1 meter by 2100. These are the facts, and you can imagine the consequences. For example, if there is a sea level rise happening, wouldn't that lead to submergence of coastal communities? Wouldn't that lead to submergence of small island developing states? Right? This can happen. Arctic sea ice we are seeing, so of course the ice sheets are melting. This is also a problem. Overall, this area is very much facing issues. Okay. Now, then we talk about glacier retreat. Yes, glaciers across the world are retreating. Okay, to almost 1 meter per year on an average. Okay, glaciers across the world. Think of mountains, think of snowy mountains, they will have glaciers. Glaciers are retreating throughout the world. Again, think why? Temperature is increasing. We have seen global warming, right? So in global warming, we are again seeing that yes, the temperature is increasing. So first, I have been directly showing you what are the facts, and then we will put each of these facts in proper ecosystem, and then you will easily understand that yes, so many things are happening throughout the world. That is going to be the major highlight for us. So again, what all we have seen, let us summarize very quickly. Carbon dioxide concentrations rapidly increasing, surpass the safe level of 350 ppm. Sea level rise by 2100, 1 meter rise is supposed to happen. Arctic sea level ice is receding, so your glaciers are also receding. Okay, these are some of the major facts that we have seen. All right, now we'll also see one thing here. Let us go back to the part of WMO. Okay, so again, one is greenhouse gases we've seen. Okay, other than that, we've seen sea level rise, we have seen Arctic, and lastly we had seen glaciers. 4 things and facts related to all of them. Now for WMO, please remember, WMO has said 2011 to 2020 as the warmest decade. Warmest decade, fine. And it has said 2023 as the warmest year ever. When I do the current developments, I'll tell you specifically what are the reasons for this. But for now, we remember that World Meteorological Organization has talked about this being the warmest decade and 2023 being the warmest year. Okay. Other than that, it had spoken about, for example, oceans. Okay. So around 60% of the oceans had faced marine heat waves, and almost similar things, that glaciers are receding, Arctic is melting, even Antarctic is melting. All these points will go hand in hand. Okay, so again, I don't want you to bombard with a lot of facts, even if you remember these. Okay, and even here you can be choosy. Okay, for example, basic facts, if you are able to remember and recall, that is going to be good enough for us. Fine. So this is one thing that you have seen so far, that 2 major institutions, IPCC and WMO, what are they saying? Okay, now I have been speaking about the ecosystem approach. Let us see that what we can understand here in our ecosystem approach. Okay, so see, whenever we talk about increase in temperature, for example, or we can talk about climate change in general, you have to think about land and sea. Okay, so for example, we have land, right? And we also have sea, or I can write even down oceans. Now here we will follow a very simple approach, so that first you are aware about what is there. Okay, now on land, whatever ecosystems that you are able to remember, first of all we'll write that. Okay, so for example, you have mountains. Okay, you have forests, there are grasslands, there are deserts. Okay, there are, for example, agriculture areas, I'm writing agri here. Okay, you have urban areas. And not just that, you even can write about other areas, for example, even the presence of wetlands, let's say your ecotones. Okay, all these are some important areas, right? From mountains, forest, grassland, desert, agriculture, urban areas, wetlands, right? These are for one of the basic things you need to know. In oceans, for example, so one, you can think about open oceans, okay, normal oceans. You have polar oceans, okay, which have a lot of considerable ice sheet. In oceans, you can even think about specific ecosystems, okay. You can think about corals, and you can even think about kelp forests, okay. For example, I can even add the coastal areas if, okay, for example, between the land and oceans, one areas, etc., will can also be coastal areas. Now, if a very basic understanding you will have about these land and the oceans, okay, and very organically, if you think about each of the important points, you can easily answer a question. For example, if the question simply says, what is the impact of global warming on the world, you can divide it on land, what is the impact? On oceans, what is the impact? Similarly, if the question is, what is the impact of climate change on the world, same format you can have on the land and on the oceans. Then what is the impact of climate change on India? Same format you can have, and you can generate at least 10 or 11 points. Fine. So first, what we have written, we've only written the important keywords here. Now what we can do is to add details here so that we can remember. Okay. Now, for example, mountains. Okay. Now in mountains, of course, what comes to mind, okay, is you can have glaciers. Okay, let me use another pen so that we all can remember better. Okay, for example, we can have glaciers here. Okay, so on the mountains and in these alpine regions, one, if there is a change of temperature, the biodiversity, flora and fauna would change. Melting of glaciers, etc., can happen in the mountains. Fine. Talking of forests, if there is too much of high temperature, what will this lead to? This will lead to forest fire. Okay. Similarly, when you have grasslands, if in grasslands, of course, if there is higher temperature, if there is more of climate change, what will you see? Not just in forest, but in all these regions, one, productivity or the yield can decline. Okay, same for deserts. There will be more of desertification and degradation. Okay, more desertification. And again, remember, this you can also link with agriculture, deserts and agriculture. If more and more land, if more arable land is becoming a desert, the land available for cultivation will reduce. Think this and think then SDG2, food security, again a problem, right? Similarly, when you think about agriculture, again we are seeing temperature is increasing. WMO telling us if there is 1 degree increase in temperature, the yield almost reduces. The yield almost reduces by 6 to 10%. The agriculture yield reduces by 6 to 10%. Fine. And when I say agriculture, not just the yield, we'll also see this in more detail in agriculture. There are more pests, there are more diseases. The plant needs more attention. Why? Because the water will evaporate faster. It will now need more fertilizers to support it. Again, a problem. Okay. Then in urban areas, again, if you think if there's more heat, more warming, what will happen? Urban heat island effect, urban heat island, and link this with heat waves. The urban areas facing a lot of heat waves. By the way, the oceans also face a lot of heat waves. For this part, I'll just use this color. I hope this makes sense to you. You have marine heat waves. What did we see? The marine heat waves also increasing. Okay. Now, if there is more warming of the coasts, if there is more impact of climate change, what again can happen? There are coastal areas. The coastal areas might face flooding. There can be more flooding. This flooding can also lead to coastal erosion. So think of any, and when I say coast, again imagine India's coast, Arabian Sea and Bay of Bengal. Again, what can happen? Arabian Sea, more tropical cyclones can occur. Okay. So just one by one, I'm just introducing points to you. Okay. So this will get better with time. So one, flooding can happen. Okay. Then if I talk about oceans, in the open oceans, okay, there is increase in temperature. The temperature will increase, and see, when I'm talking of impact of climate change on both land and oceans, please remember, both on land as well as oceans, the temperature will increase. Okay, temperature will increase, but on which the temperature increase will be more? It is going to be land. On land the temperature increase is higher, whereas in oceans it is overall lower. Okay, now here also I'll just in the next slide also tell you, for example, with respect to temperature, that from 1850s to now, overall there is a 1.2 degree Celsius increase in temperature. 1.2 degree Celsius. Now, of course, on land this was greater as compared to seas or oceans. Okay, so from 1850 to right now, overall till now, the temperature increase that has happened has been 1.2 degree Celsius. Again, we can quote reports of IPCC here, WMO. Fine, coming back, temperature is going to increase, right? And again, if temperature is going to increase, what will happen? The marine biodiversity, that will face a problem. Marine biodiversity. In the polar oceans, again, what will happen? Melting of ice sheets. Melting of ice sheets. Okay. And when you write melting of ice sheets, you can be even more specific. Melting of Antarctic or Arctic ice sheets. Okay. Again, as I move, I'll tell you even more specific examples here. Corals. Now, coral bleaching is very prominent, especially in the Great Barrier Reef of Australia. So, increased temperatures can lead to bleaching of corals, and corals are very important for marine biodiversity. Okay, that they almost represent 1/4 of the marine biodiversity, the coral reefs. Okay, so saving corals is very important. And then lastly, again, if there is more of temperature increase, even the kelp are your macroalga. Okay, these are the macroalgae, and they also support a lot of biodiversity. Even they will be under a lot of stress. Even they will be under a lot of stress. Fine. So what we are seeing overall, that coastal areas, oceans, fine. For example, I also mentioned wetlands. Okay, they will also be threatened. There will be a shrinking of wetlands, shrinking of lakes. Okay. For example, Aral Lake has shrinked almost 99%. Okay. There are, for example, Lake Urmia in Iran. All these lakes are shrinking. One of the reasons is climate change. Okay. So again, a very basic framework. All of us can easily imagine all of these things happening, right? You think of ecosystem, think of land, and think of oceans or aquatic ecosystem, right? Think of mountains, forest, grassland, deserts, agriculture, urban areas, wetlands. At least these will always be the points you can always think about on the spot. Similarly, in oceans, we can think about at least the coastal part. Okay. We can think about the open oceans. We can think about polar oceans. We can think about coral reefs. We can think about kelp forests. Okay. So at least this is something we can have in our basic mind. Okay. And then based on this, we can still have a more nuanced discussion. All right. So again, if this is one thing, I hope this is clear to you. And again, if you have this sorted and if you have this very much done, all you have to do is to then just change the examples. For example, if the question is on deserts, write down, for example, in India, case of Thar Desert. If it's global, write doubts about Atacama Desert, Sahara Desert. So ultimately, if you're able to nail this down, this is what is needed. Fine. And again, one more way to visualize this can be that you can mention this. Okay. So for example, we're talking about for example, you're talking of impacts of climate change. So one part we've just saw related to land. Okay. Now this, just all the things we saw, I can just mention it here so that when I have to now write down newer things, I can even add it here. So right from mountains, forests, grasslands, deserts, agricultural lands, okay, urban areas, and of course we also saw the case of, for example, wetlands, ecotones, okay, and similarly for oceans. Okay, so then the more familiar are you drawing this, the better it is for you. Okay, so I will write down open oceans, polar oceans. Then we can write about corals, kelps, and coastal ecosystem. Okay, and here also just keep in mind, this can easily be thought as at the level of global, and this can also be visualized at the level of India. Okay, that is why the moment you are very sorted with this, all you have to do is to add your current affairs and the facts, and every time you will have something unique. Fine, keep this in mind. And remember, from 1850 to now, almost 1.2 degrees Celsius increase in temperature has happened. Okay, now what is not mentioned here, you can mention about extreme weather events, increase in the extreme weather events. Okay, so again, this is a way of consolidating all the information, all the dimensions in one. Increase in extreme weather events, and this is also what I'll cover. Okay, so extreme weather events have increased both in the frequency and in the intensity. Think of tropical cyclones, think of floods, etc. Okay, so if you have something like this is definitely going to make your job easier. Fine. So I hope till now, let us go back and just see our framework. What all have you been able to understand? Okay. See, what about climate change? So in what we just saw, sustainable development goals, basic definition of global warming, climate change. We saw what are greenhouse gases. We saw evidences by IPCC and WMO, and we just saw that when the temperature is increasing, what impact will it have overall, a very at a basic level across the ecosystem. Because if these evidences are clear, and that is what we saw, okay, that in all these regions we are seeing, because of increased stress, see, glaciers are receding by almost 1 meter per year. Okay, similarly in a lot of regions we are facing a lot of instability. So these are what we are seeing overall. Now let us go to consequences, and after that we will again go into the impact in more detail. Okay, we've already seen a part of it. When you do this, you will understand it even better. Fine. Now let us talk about the causes of climate change. Okay, now, okay, in the causes of climate change, again remember, any of these things, okay, if there is talk about the causes, what we will always try to think about, okay, we will think that yes, there will be certain natural causes and there will be certain man-made or anthropogenic causes. Because again, if you get a 15 marker on climate change, these are some of the areas or points you should never miss out on. Okay, now what are the natural causes of climate change? One, I can easily say, if there has been a volcanic eruption, Now, volcanic eruption will lead to emissions of some greenhouse gases. It can also lead to emissions of certain aerosol. For example, it can lead to sulfate aerosols. Okay, so again, if there's a volcano, it erupts, some gases are released, some aerosols are released. Now, aerosols, what they will do, for example, these are aerosols. If there is incoming sunlight, they will reflect the incoming sunlight. Because they reflect the sunlight, they help in cooling. And the greenhouse gases, they of course help in warming. So overall, what we will see that because of volcanic eruptions, there will be changes in how the earth is heated and how the earth is cooled. That is the basic idea. Okay. So volcanic eruptions are one of the basic natural causes of climate change. Okay. Then there can be solar variations. Okay. There can be certain solar variations. For example, incoming sunlight. Now, solar variations, in your science, you read about something known as the solar cycle. Okay, approximately 11 years. Now, based on the sunspots, solar cycle, solar incoming radiation, how again the earth is heated and how it is cooled is also going to be impacted. So, this also is one of the natural causes. That is why naturally the greenhouse gases are emitted here. Okay, and naturally also, for example, we saw greenhouse gases emitted here, and then how at the level of sun, how the variation can happen. Both these things can happen. Then again, if you think about, for example, El Nino, and basically I can talk about ocean currents. So the ocean currents can also impact how the earth is warming. In fact, it is seen in an El Nino year, it is generally warmer. Okay, so even this is something that can lead to natural effect. Other than that, there can be natural greenhouse gases emitted, which can again lead to more warming. Okay, so here now natural, see for example, methane is there. Methane is naturally emitted from wetlands. Okay, methane is naturally emitted by termites, by livestock. So this is going to lead to again increasing greenhouse gas emissions. Similarly, carbon dioxide also has a natural component to it. So even this can also be a natural greenhouse gas. Okay. So volcanic eruptions, solar variations, ocean currents, for example, El Nino, natural greenhouse gases, all of these are natural factors contributing to climate change. Okay. And last, if you want to even add, can be orbital variations. Okay. So again, if you have Earth, there is a axial tilt, 23.5 degree, Earth is tilted. If Earth is tilted again, and Earth is, there is rotation. So again, whatever incoming radiation is happening, because of the orbital variations, there will be changes in how Earth is getting heated and Earth is getting cooled. Okay, so remember this, changes in orbital variations leading to changes in how Earth is getting heated and Earth is getting cooled. Fine. Now, anthropogenic, this means man-made. Okay. Now, here what we'll try to see. Okay. Causes of climate change here. Okay. Now, in anthropogenic, we can write a lot of points. For example, burning of fossil fuels. Will this lead to? Okay. Yes, this will lead to climate change. More of the greenhouse gases are released. Similarly, deforestation. Yes, this can also lead to. Okay. Then land use pattern change. For example, if we take more of land into cut down the trees, more of this is used in agriculture, more of this land is used for real estate construction. All these activities will also lead to more emissions of carbon dioxide, other greenhouse gases. This can also lead to problems. Fine. Then again, due to a lot of man-made activities, aerosols are released. You can think about, okay, a lot of aerosols being released in terms of, let's say, refrigerants, okay, in terms of other gases. This can also lead to cooling impact, and overall this can also have a this can also affect the climate change, right? Other than that, okay, for example, hydrofluorocarbons, what are these? These are refrigerants, and they are also what? Greenhouse gases. So widespread use of HFCs, which was being done, of course, it is now phased out under Kigali Amendment to Montreal Protocol. But even HFCs, you can say that they were a huge anthropogenic source of climate change. So even this can be added to the sources we are discussing. Okay. Other than that, you can mention a lot of industrial processes. We can even mention waste management. All of this is going to lead to, or these are all man-made industrial process leading a lot of pollutants. Similarly, waste management, again, when you burn off the waste, incineration, pyrolysis, in doing all these processes, then again a lot of emissions are there. So this one slide is going to help you consolidate what are the causes of climate change. Okay, very basic, something we should be aware about. Okay, so here, see, whenever you are asked a question, be it causes, etc., one way is to just write down 1, 2, 3, 4. But even a better way is to segregate it further. Okay, natural, man-made. Similarly, ecosystem wise, if you also went, you can also write down 7 or 8 points. But again, it is better. Think of land and think of oceans, and this will also help you remember better. So even this is something that we can understand and keep our mind in. Okay. Now, what is the effect of global warming on a global climate? Okay, because we are discussing global warming, now you can easily answer this kind of a question. Okay, what is the effect of global warming on a global climate? All you have to do is to think about the basic framework. Okay, the what is going to be the impact, and based on this you can write down as many points as you want. Now notice here the question says effects of global warming. Okay, so of course we are going to write about temperature related points. Okay, and this is something we have seen. Now just one thing, if we have to talk about effects of global warming, one question can be again, why is this happening? Again, we have seen the reasons why this is happening. Number one, record greenhouse gas emissions, both carbon dioxide, methane and other greenhouse gas emissions, they are increasing at a very rapid level. What is the direct consequences? Increase in temperature. Again, link and think about WMO, 2023 warmest year and the warmest decade. So you already know which report to use and where to start. Okay, this is something we already know. All right. And if you already know this, then the things will become easier. Okay. So for example, we can then talk about each and every part here. So again, we'll think about the each WMO part. Okay. And then for each and everything. So again, I'll just go back, okay, to the data what we had. Okay. So first thing is we'll tell about WMO. One second. Okay, yes, we'll have this here, right? So one, we'll talk about WMO talking warmest decade or the warmest year, and then one by one we'll talk and open all these points. Fine. See, on land also temperature has increase in temperature, and on oceans also the temperature has increased. Both of them have seen a temperature increase. Okay. Now one by one, see, on mountains we can talk about glacial retreat. Remember, 1 meter retreat per year. Okay, 1 meter per year. Forest fires. Okay, so here we can think about, and now I'll give you specific examples, more examples. Think about Amazon forests. Think about Spain bushfires, Australian bushfires. Okay, in all these regions, what we had seen, because of increasing temperatures, they were more prone to forest fires, right? So this was directly seen many a times. Then at the level of grassland also, there was limited yield available. So this also. So again, think of llanos, okay, campos, or different grasslands over all the world. So one, the growth of the grasses will also reduce. The availability or the nutrition availability will also reduce. So this will lead to, again, the livestock not being having enough grasses to feed on. Again, a problem. Then at the level of desert, Okay, so again I've told you, think about Sahel region of Africa. Sahel region of Africa. Okay, now this region again has a lot of uh, a lot of states which are struggling with climate change, and this also is leading to, then later on in the consequences we can think about political instability. Okay, so Sahel region of Africa. Similarly, Thar Desert in India. This region again, very high temperatures, so high fluctuation, very hot, very cold. Fine. Then the area is not at all fertile. So again, there is a lot of issue of water availability of agriculture around the region. Fine. And there is more and more desertification happening throughout the world. This is also a problem which the world is facing. Okay. In terms of agriculture, one point I'll tell you right now, because agriculture we'll see as a separate dimension very shortly, that overall, if there is 1 degree Celsius increase, there is 6 to 10% reduction in the crop yield. 6 to 10% reduction in the crop yield, right? In urban areas, of course, we have in many cases seen, okay, you have heard terms like concrete jungles. Why concrete jungles? Okay, because again there is so much of heat generated. Okay, this is getting trapped and it is not going to go out. So comparing rural areas versus urban areas are comparatively warmer, and if urban areas are comparatively warmer, there is higher energy demand in these regions. Okay, this is also happening. Wetlands, etc., we've seen areas or lakes shrinking overall. Okay, so here I think two examples I've given you. One is Aral Sea, Lake Urmia. Okay, in India as well, we have seen lakes, for example, in Bangalore, in other regions, they are shrinking. All these can be proper points for us, right? Now, in oceans, for example, we have seen increased incidences of marine heat waves. Okay, there are more than 60% oceans is having marine heat waves. Heat waves are happening here in land also, but in oceans also considerably increased. Fine. Coastal areas, because of increased temperature, is facing what? If there is increased sea surface temperature, what will happen? There will be more tropical cyclones. We are seeing tropical cyclones both in the Arabian Sea and the Bay of Bengal. Okay. For example, if I say tropical cyclones, I can again give example of cyclone Amphan. Okay. Cyclone Biparjoy, cyclone Remal being the most recent one, cyclone Midhili. Okay, cyclone Mocha, MOCHA. So whenever we say, if from now, if you say cyclones, at least 3 or 4 examples you should know. Okay, at least one example if you end the point. So if you have things handy, always better. Okay, cyclone Amphan, cyclone Biparjoy, Remal, Midhili, Mocha. Okay, so this is also what we can think. Open oceans, we've already seen the temperature of the ocean, open oceans increasing. Okay, the temperature here has been increasing. Of course, not as much as the land, but again, approximately around 0.8 degrees Celsius increase has been happening here in the region. Okay, this is also something to note. In the polar part, yes, where is the rapid melting of ice sheets? Okay, so here one example I can give you is the Greenland ice sheet rapidly melting. Okay, similarly in the Antarctica region. Okay, so for example in the oceans, if I have to tell you, in Antarctic, A23A ice sheet rapidly melting. Again in Antarctic you read about Ross Sea, Weddell Sea. Again the different icebergs or ice sheets in the region are melting, which is directly telling you if their temperature is increasing, of course this is going to melt. And if the oceans are seeing melting, what will happen? Sea level rise is going to happen. So all these things are interrelated. Fine. right? So what this is also what we've seen. Ice sheets, Greenland, please remember A23A, etc. In corals, there is coral bleaching, Great Barrier Reef. There is also the fourth global coral mass bleaching event in this region of Great Barrier Reef. Okay, and again, coral bleaching is going to be very much dangerous for the ecosystem because a lot of marine biodiversity is supported by the corals. And then lastly, for example, we see kelp forests. Kelp forest, again, if the temperature is getting higher in the oceans, what will happen? If the temperature is higher in the oceans, we will see more of destruction of the kelps. Okay, so this also is going to happen, right? Now, a couple of things extra, for example, just for our, for example, when we are saying oceans, if they are facing increasing sea, of course, oceans will face increasing temperature. Increasing temperature, for example, will lead to more extreme weather events. For example, in this case, tropical cyclones. Always remember this term, extreme weather events. And no, I'm talking of frequency as well as intensity of extreme weather events. Now, increasing temperature is happening here. Other than that, there is ocean acidification happening. Okay, carbon dioxide becoming carbonic acid. If there is more ocean acidification, the pH of the ocean, for example, if the pH was, let's say, 7, 6, it will become 6, 5. Ocean pH is becoming more acidic. Ocean acidification is happening. Sea level rise, okay, increasing temperature, sea level rise is happening. With sea level rise, what we'll remember? 1 meter sea level rise is expected by 2100. You can imagine the consequences, okay? Submergence, etc. All of this can happen. Then there can be ocean deoxygenation. That basically means the dissolved oxygen will reduce. Ocean deoxygenation. See, as then when the temperature increases, the solubility of carbon dioxide will be impacted, number one. Second, the productivity of the oceans will also be impacted. If there is ocean deoxygenation, after a point, there will be more and more of dead zones being created. More and more dead zones. Now, in the topic of pollution, I'll also tell you, and by the way, you would already know about a thing known as eutrophication. Eutrophication means nutrient enrichment, especially nitrates and phosphates, they are increasing. Okay, so even that can lead to algal bloom, and even that can ultimately lead to formation of dead zones. But even the increase in temperature, okay, this can also lead to these areas. So again, in oceans, temperature is increasing, no doubt about it. Ocean acidification is happening, sea level rise is happening, and ocean deoxygenation is happening. Okay, these are the few terms that I want you to remember. Similarly, for land and oceans, we basically seen the framework. Now things will be very easy for you to understand. Okay, so example, if you have seen the effect of global warming on the global climate, okay, so here also, for example, we have understood the major things that are happening right from the melting of Arctics. Okay, we've seen increase frequency and intensity. Okay, this is one point I'll write down extra here. Okay, because this is overall important, frequency and intensity of extreme weather events has increased. And here prominent examples, you can write down cyclones, okay, again hurricanes, etc. have increased overall throughout the world. So this is something that we will understand, okay, that the hurricanes, heat waves, or heavy rainfall, all of this has increased. Okay, other than that, coral reefs points we've already seen. Okay, we've seen what changes this can happen. Okay, 1 or 2 points because biodiversity was not mentioned there. So one is frequency and intensity of this. Other point is there is going to be a loss of biodiversity. Whenever you write biodiversity, you can even quote IUCN. You can quote WWF and highlight that increasing temperatures can of course lead to species extinction. This can also trigger mass extinctions. This can also trigger mass extinction. Now, when I say the word mass extinction, right now we are talking of sixth mass extinction. Why sixth mass extinction? The previous 5 mass extinction were brought about by natural factors. We saw natural climate change, etc. But the sixth mass extinction is overwhelmingly human. Clear evidence that is because of human made activities that there is a problem. That is why we had seen this slide. Causes of climate change. As per IPCC report, as per WMO report, it is overwhelmingly clear that anthropogenic reasons are now the primary factors for causing climate change. There is a overwhelming evidence, right? That is why we discussed all these areas, that increase in carbon dioxide, increase in other parameters directly telling us that the climate change is responsible because of human made activities. Okay, I hope that is one part that we'll also remember, right? Overwhelming evidence about the human impact. Fine. So this is where we will remember the sixth mass extinction as well. Okay, sixth mass extinction you will also try to remember. Fine. Now, if we have seen the effects, okay, of global warming on climate change. So one, this is temperature specific, right? Then again, we have seen what can be the consequences of climate change. Now here, I will open up certain dimensions. Fine. And here, two kind of questions can be asked. I've already told you. One, general, they can ask you for the word. Then what they can do for India. For India and the word. Okay, so if you remember the basic framework, what we have discussed, you will be able to easily answer whether for India or the word. Okay, both these things you will be able to answer. Fine. Now, what are the consequences of climate change here? Okay, if you have the framework in mind, okay, let's again just have a look at. If you remember this framework, okay, all you need to know, okay, or perhaps in your just notes, just think like this. For all these regions, what are happening? Okay, what we'll try to see, environmental, you are already seeing environmental consequences. For example, this is the easiest part to remember. Okay, in the environmental consequences, of course, there will be forest fires, coral bleaching, kelp forest. Environmental, we have seen environmental consequences. We are more interested to know, for example, political consequences, for example, social consequences, for example, economic consequences. Okay, then for example, cultural, technological, right? So what we will do one by one, we'll try to see that, and again here try to see the line of reasoning and the examples, because if you are able to master this, you are able to generate points on the go. That is again going to be the USP of the course. That is what you should be focusing on. Okay, that whatever points are you able to think. Now, environmental, of course, we know that forest fires will happen. Okay, and forests are a great source of ecosystem services. Coral reefs, you lose them. Kelps, you'll lose. Urban heat island effect, agriculture wise problems will happen. So now one by one for these areas, okay, there are going to be multi-dimensional impacts. So I'll again start with environment, okay, and for each part I will be giving you examples here. Okay, so now based on the framework that you know, okay, we will keep on writing some dimensions. Now let's talk about environmental impact. Okay, and when it's always better, and by the way, yes, environmental consequences, right? Now see, one is the basic thing, the sea level is rising. Okay, if sea level is rising, think about countries like Maldives. These are low lying countries, heavily dependent on tourism. There is a huge threat of submergence. Maldives, Tuvalu Island, etc. Sea level rise is going to threaten them. Life is at threat. If coral bleaching is happening, Again, think about the impact on the Great Barrier Reef of Australia. So one, environmentally, what you are doing, you are losing out the biodiversity. Second, this region also then loses a lot of tourism. Economic loss is there directly. So economic loss because of environmental loss. Okay, so this again is a direct consequence here. If you talk about coral bleaching in this region, okay, then if there is rapid melting of glaciers, rapid melting of glaciers will happen. Now, what will this lead to? Rapid melting of glaciers. Of course, example I've given you: Greenland ice sheet rapidly melting, Arctic ice rapidly melting, even in Antarctic. Okay, for example, A23A ice sheet, etc. If all of these ice sheets are melting, okay, so think about the impact on the coastal regions. Coastal regions will be under threat, and this can also feed to this sea level rise. So rapid melting of glaciers, sea level rise, coral bleaching are all of the environmental issues or the environmental consequences that we face. Okay. Fourth is something we've already seen: extreme weather events. Frequency and intensity of extreme weather events, be it tropical cyclones, be it typhoons, hurricanes, all of that is increasing throughout the world. Okay. And extreme weather events, you can again link it to disasters. Now, I told you there is a lot of interrelation in climate change. One, it is interrelated to SDGs. But second, I'll use another color so that you remember. It is also interrelated to a topic which we will also see: disasters and disaster management. Climate change leads to more extreme weather events. Again, the resilience of the countries or the coastal communities to that disaster becomes very important. Okay, so this is also something we have to keep in mind. Okay, so extreme weather events, frequency and intensity is increasing, more disasters. So again, the vulnerability of these communities will come to mind. Okay, so this is something again we'll remember. Fourth and the fifth part here also related to the environmental consequence is loss of biodiversity. There's going to be a loss of biodiversity as well throughout. You can quote IUCN, I just told you. So these are the environmental consequences of the impact. Okay, so again remember there are two things. One is impact. These are the impact of climate change, and based on the impact there will be consequences, right? So this is something that we will remember, that yes, direct impact is, for example, in this case at the mountains, okay, receding of glaciers, but this will lead to movement of people that we'll see in political, for example. Okay, so these are the environmental overall consequences that we see. Okay, now at the level of economic consequences, okay, so here I think one, tourism loss, okay, and again loss of lives, livelihoods and property. This will go hand in hand. For example, if there is a tropical cyclone on the Indian coast, okay, lives will be lost, livelihoods will be lost, and property, infrastructure, that will also be lost. Tourism loss will happen, again link Great Barrier Reef, for example, or other areas which have high marine diversity. Okay, you can make it even more specific. For example, fisheries, aquaculture will be impacted because of climate change and global warming. Death of fishes can happen, dead zones can be created, this can also go hand in hand. Then we can also talk about agriculture. So what we saw: land, agriculture, more desertification will happen, crop yield can reduce. If crop yield will reduce, think about the impact on food security. Think SDG2. This is directly seen in Africa, in Sahel regions, when there is huge poverty, hunger, malnutrition, And again, if agriculture is impacted because of climate change, this can also lead to more health related problems, diseases, more health problems. Okay, so this is again going to be a direct consequence here. Okay, then you can, so infrastructure, I think we've already seen, aquaculture, all of this. Additional one point I've already told you, okay, that there will be increased energy cost. There is going to be an increased energy cost because again in the urban areas, if there is urban heat island effect, more energy is going to be used, more energy needed, and similarly for other regions also, energy requirement will be higher in general. Okay, so this is going to be majorly the economic impacts. Okay, now at the social level, there will be issues. Okay, so here think about, for example, Kiribati Island. Okay, the people here will be forced to migrate because of this. Kiribati Island is a small island developing state, so people here, they will be forced to migrate. This can also, so displacement migration is going to be there. Example, for example, Bangladesh, vulnerable to Bay of Bengal, cyclones in the region. What will this lead to? Social distress. What can again lead to, there are almost, India and Bangladesh, they share 54 rivers. Okay, and out of this only Ganga and river Kushiari, for that river agreement is signed, but for other rivers, if there is more flooding, this can also cause problems. Okay, so at the social level, one is displacement, other is migration related problems. This is also something for us to keep in mind. Okay, displacement. Okay, and then of course at the social level, think of water security, food security we've already done, but again water, a very scarce resource. If there is more heating of land, if there is more receding of glaciers, more shrinking of lakes, again the availability of water is impacted. If availability is impacted of water, people will face issues. Number one, people, agriculture will face issues. So even this is something which is going to be problematic if this is not taken care of. Okay, so even this is something we can understand. So environmental, economic consequences we can understand, right? And we can extend the logic of social to even international. Okay, again please, in the international level, what you can think about, okay, again conflicts that happen, the concept of climate refugees. Okay, here also again think of regions in Africa, okay, which ultimately leads to instability, military coups. Here also we see an impact of climate change because again the resources that were already available, they are getting strained, and because of that, either the people are forced to move out. If the people are forced to move out, think about the loss of demographic potential. Okay, that is getting lost. Other than that, of course, the shrinking lakes and rivers also have international consequences. Okay, the nations can also, they can be in the future threat of water wars also. So even this can be an issue that can be thought about. Okay, and again here I think one example I've given you can be used both. This Kiribati Islands is planning to relocate all its people to another area. So one, its social bonds are getting impacted, but again at the international level, what this will set an example, the small island developing states, other example, Marshall Islands, Tuvalu Islands, all of them are under threat. So even this can be seen, right? In the international levels, what we have seen, something known as day zero in South Africa, a day when all the water will not be, no water will be available. This can also lead to international conflicts in other regions as well. Okay. Similarly, right now, even the Israel Palestine conflict which is going on. So you can even link this, for example, the water scarcity in the region of Lebanon, Jordan, Dead Sea, in all of that part, this also heightens the level of resources available. So at the international level, you can also imagine these kind of conflicts that can arise from this. Okay. And the most important point which we'll see in lecture number 2 is at the international level, developed versus developing fight goes on. Okay, which is where we see United Nations Framework Convention on Climate Change, for example, and other conventions to properly understand what is happening in the international arena. Okay, so this is also something that keeps on going. Okay, so at the international level, social level, economic level, okay, we can think about. And lastly, two more small dimensions that I want you to also think about. One is cultural impact, okay, or the cultural consequence, and then can also be a technological consequence. Okay, and again, in all of this, all we have to think about is overall idea. Okay, now culture, think about the communities living in the Arctic region. Okay, so there, if their region is under threat, their cultural heritage is also under threat. Okay, so the tribes in the Arctic region, etc., they will face consequences because of climate change. Okay, then for example, I can give you example of the Maasai herders from Kenya. Now because of climate change, their ways of living with the nature to be dependent on traditional livelihoods, even that is getting impacted. Okay, so traditional knowledge and the traditional livelihood, this is getting impacted for sure. Okay, so Maasai herders in Kenya, etc., Arctic nomadic communities, etc., they are also facing a loss of cultural heritage. Okay, and again, culture, think of historical sites in Rome, in Venice, Italy, in many other places. They are also impacted because of climate change. Okay, because of increased warming and increased stress on the regions. So even the cultural sites, the cultural communities are also under threat. And last is technological. Now because of climate change, a huge discussion is happening on mobility. Okay, especially for example, I can talk about electric vehicles. Okay, why is this happening? So again, this is again, of course, you can say that this is a good impact consequence, that a cultural and also a technological transformation is at least happening to reduce carbon emissions. What can be done at the technology level, this is also being explored. Okay, so even this is where the better mobility is being thought about, use of electric vehicles, etc. So this is also something that we can just remember. Okay, this also we'll see in later detail, that industrial transition is being planned. Okay, you can think about green or let's say alternative technologies. Okay, this we'll explore in more detail in lecture number 3 when I talk to you about energy transition overall. But these are the major updates that are happening. So technological consequences in the terms of energy, green technology, mobility, electric vehicles, cultural, okay, at the international level, at the social level, economic, environmental, okay. But the edifice for all of this and how everything generates is the foundational basic. If you understand what is happening on the oceans, if you understand what is happening on the land, and again the extreme weather events, this is all that we have to take into account. Okay, this is all that you have to remember, that based on the basic ecosystems and then their respective dimension. If you have clarity on this, trust me, if there's any question asked, not only on this, but this is again an exercise in thinking, you will be able to generate a lot of points and then of course get very good marks overall. Okay, so I hope till here you are able to follow. Okay, now again same question can be transformed. So again, if you again are following, for example, what are the consequences or even what is the effect or the impact. Okay, if the same question is asked, now they change it to India. Okay, same things you can change. Sea level rise, you can write about the coastal communities. Okay, you can talk about Bay of Bengal, you can talk about Lakshadweep, you can talk about Andaman. Okay, coral bleaching again can impact Andaman, Lakshadweep, etc. Rapid melting of glaciers is seen in the Hindu Kush region. Okay, extreme weather events, of course, the cyclones I gave you examples of Biparjoy, Amphan, all these are in India. Okay, loss of biodiversity is happening in Western Ghats, in other parts. So, point is, all these points can be tweaked. Okay, and then of course you can write this as per Indian demand. So, if there is a question either on the global ecosystem or on the Indian ecosystems, now all of you should be able to write it. Okay. In agriculture, you can talk about in India, Saurashtra, Vidarbha, the more water scarce regions, how they are under threat. This point should not be ignored. Okay. So again, I think now, so again, this is how you prepare. If you prepare a basic template, you can modify it as per the demands. Basic question on global warming, basic question on climate change, or on global world, or on let's say India, you should be able to answer. Fine. I hope till here we are able to follow and we are on the same page. All right. So this is something I think, one second, you'll be able to answer. All right. Now, some specific more points that we can see. Now, this year specifically, and since the last 1 or 2 years, cryosphere has gained a lot of relevance. Okay. Now, what does cryosphere have? A very simple diagram. If ever you get a question, you can just, you don't have to be very elaborate here. Just remember, you can show ice sheet, you can show permafrost, and here, of course, ice shelves, ice seas, snow, glaciers, right? I had been telling you about the melting of glaciers being a common cause of concern, right? Now, remember, whenever, for example, permafrost, if this is going to melt, the name is permafrost, permanently frozen. What will this release? It will release methane, it will release oxides of carbon, it will also release, for example, whatever bacteria, okay, or diseases that are present. That can also happen. Okay. Now, talking of bacteria and diseases, climate change also is related to health. Climate change is also related to health. Now, because I've mentioned this, I'll again just go back here. You can even add it to the social part if you want. For example, I can just mention the health part here. So, water security written, also write down the health. How? One, it leads to more vector-borne diseases. Now, because of climate change, the hotspots available for the mosquitoes to breed, they increase. Okay, so one is there is increase of mosquitoes. If the mosquitoes are found in more regions, more mosquito spread, so more vector-borne diseases can happen. Other than that, for example, melting of permafrost, this can also release bacteria or certain vectors responsible for spread of diseases. Okay, so this can also happen. Melting, or I should say thawing. Thawing also means warming or melting. Thawing of permafrost. Other than that, for health and climate change, again, more pests, okay, and diseases happen in agriculture also. As the temperature increases, again, it becomes more fertile ground for the spread of these diseases. So this is also something that we can keep a eye on. Okay, so this is also something that happens. Okay, so health part, always remember that climate change is also directly linked to health. Fine. Glacier melting, I've already told you. Okay, 1 meter per year receding snow. Okay. Now, talking of cryosphere, for example, if again, what will happen if this ice is going to melt? Okay. So here also you don't have to worry. Okay. So for example, if a question is again, what is the impact of melting of glaciers? Okay. If the glaciers are melting, okay. So again, what will this lead to? One, it will lead to sea level rise. Okay. It will impact the flow of rivers. In the short term, the rivers will have more water. Okay. However, in the longer run, the source of the rivers, a perennial source, if that is exhausted, the rivers will dry up. Of course, the melting of glaciers can lead to glacial lake outburst flood. When you write that, just write down the example of South Lonak Lake in Sikkim. This is again an example from current affairs. That is what we'll do. Of course, we see this in more detail in our lectures on disaster management, how these happen, how can they be controlled, etc. But again, glacial lake outburst flood is something that we see. There is, of course, a rapid sea level rise. At the level of rivers, they will have more water initially when the glaciers burst, but they would also dry up when these glaciers ultimately recede. And when you write that, you can mention the glaciers of Hindu Kush and other regions in general, right? Other than that, again, what will be the impact of melting of glaciers? Write about the communities dependent on them, okay? Their access to water, their access to the resources because of the glaciers will also be impacted, okay? So this is also one. Then the biodiversity which is being supported, this will also face a challenge. So again, as you see what we are doing, we are seeing at least 6 or 7 points that are there with respect to what is happening because of the melting of these glaciers, okay? So all these points one by one we can write, okay, that melting of glaciers will ultimately lead to, okay? And ultimately, see, if there is a lot of sea level rise, you can extend this point and again include the point of small island developing states like Kiribati Island, like Tuvalu Island, they would also face a problem, right? So again, we see that overall, let's say the UNESCO's report also talks about receding glaciers. IPCC talks about receding glaciers. So this is also something that is to take note of. Now in these points, haven't we covered environmental impact? We have. We've even covered the social impact on the coastal islands. We've also covered the impact on the coastal communities as well, on their livelihoods as well, and even the long-term impact. Okay, because ultimately, if the glaciers recede, long-term the impact will be that, of course, the permanent source for the rivers will vanish, and of course they will dry up, leading to drying up of the region and ultimately impacting the biodiversity. Okay, so this is how you can again structure these points and how you can differentiate it by adding the relevant current affairs in these respective portions. Okay. Okay. So for land-based components, I think we've already seen most of the components that one has to see. For example, let us go back to our framework. Okay, so mountains, glacier melting, we know. For forest, of course, forest fires, and that is more sufficient to know till here. The details of forest fires will be covered in a different portion. Desertification is a more detailed topic, but again, for now, remember that yes, land degradation and desertification is a huge challenge because of climate change. Impact on agriculture, I'll cover very shortly. And then, of course, you have impacts on urban areas. We have seen the urban heat island effect, and again on the wetlands we are also seeing the destruction, encroachment, and again the shrinking of the wetlands overall. Okay, so these are some of the points. So before going to the oceans, let me just also cover the part of agriculture. Okay, now talking of what is the impact on agriculture. Okay, till now I've only told you one point. Okay, impact on agriculture we only saw with respect to yield, that if there is an increase in temperature, let's say by 1 degree Celsius, around 6 to 10% yield will decline. Okay, 6 to 10% yield will decline. This is only as per one dimension. Okay, now we can, of course, talk about this in more detail. So, one is, of course, if the temperature increases, the yield changes. Second, not just temperature. Temperature is one, but you also have altered rain patterns. Altered rain patterns, what this leads to? This leads to shifting of growing seasons. And this is happening not just in India, throughout the world. Either the seasons are advancing or retreating by 15-20 days. Okay, shifting of growing seasons. Why? Because of changes in precipitation and temperature. So this is again a direct consequence. Now combine both these things. If the yield is declining and on the same hand if you have shifting changes, wouldn't this impact your food security? Food security, and again think for a nation like India, okay, when we have many people living in poverty and huge dependence is there of the farmers on the land available. So one, desertification and climate change can cause huge impacts overall. Okay, so these are the very first basic things that we need to know. Other than that, the points we have seen, this will lead to increase in pests and diseases. Other than that, there is requirement of more resources. Okay, by more resources we can of course mean more water needed, more fertilizers, and if there is more pest and diseases, we will need more pesticides. This also means that overall the input cost for the farmers will increase. And again, remember in the context, 86% of farmers in India are small and marginal. So if this happens, certainly this is going to be a huge problem. Okay, so water cost, fertilizers, pesticide, all of that is going to increase your input cost. Okay, so they will require more resources, there is more pest, there is a shifting of growing seasons overall. Okay, and again think again about India. This again can lead to acute water stress. And not just India, if you think of again Sahel region of Africa and again parts of South America, we are already seeing acute water stress. This is again linked directly to this. Okay, and not just acute water stress. Whenever I say agriculture, desertification, it will also go hand in hand. More and more land is getting or is under desertification, which means arability of land decreases. So this again is a problem. So not only acute water stress, but also more land under desertification, which means there should be more focus on agricultural productivity. Now, when you have to write answer with respect to India's context, think that, of course, we know Indian agriculture is dependent on the vagaries or the fluctuations of monsoon. And because of climate change, because of altered rain, cloud formation, it is the monsoon that is going to be heavily fluctuating. And not just that, also think about, for example, 2023 being a El Nino year, this is going to add to the severity. So one, you are already having more land under desertification, acute water stress, more resources needed, more pests and diseases, okay, temperature and altered rain patterns leading to shifting of growing seasons, and on top of that the yield is also declining. Okay, and if you connect this also to livestock, so one, impact is already there on the crop, but even on the livestock, for example, livestock is also facing heat stress. The yield of livestock also, for example, if you talk about cattle, etc., the milk yield, etc., will also reduce. They will also face more diseases. So both crop and livestock are under threat because of agriculture. So that is why you have to understand the impact of agriculture are multifaceted. Okay, so yield wise, shifting of season, temperature, pests, resource wise, stress wise, huge changes overall. Okay, and of course you can modify this as per India and as per the world as well. This is why climate smart agriculture is need of the hour. That you should have pests that have, or you should have crops that are resistant to pests, that have higher yield, that are heat tolerant, etc. Okay, so keep this in mind. We'll see this in more detail in coming lectures. That solution to this problem is climate smart agriculture. What are the three pillars of climate smart agriculture? That also we will see. All right, so impact on agriculture is again something important that we have just seen, right? Excessive precipitation, new diseases, okay, drought, okay, drought and ultimately desertification, degradation, right? Loss of natural resources does happen, drying up of water resources, water security, these all points we just saw. And of course there is excessive heat, more weeds, okay, disruption of pollination, again whatever we discussed, this is all here. All right, now at the level of oceans, okay, so we have seen glaciers. Again, just very few things I have to tell you for oceans. Most of the things we've already known. See, same thing, land is also getting warmer, oceans are also getting warmer. Okay, a symbolic sea levels are rising almost 3.5 mm per year and is projected to rise 1 meter by 2100. This is what I wanted to tell you, right? 3.5 mm per year and 1 meter by 2100. 1 point. Okay. Second thing, and remember 4 things we had seen for oceans. Okay, these are only the 4 things you will remember. Increase in temperature, we have seen. Sea level rise 1 meter, both these graphs also, and even if you don't remember graphs, 4 points are enough. Then ocean acidification, ocean deoxygenation, and of course you can add points related to kelps and corals. Okay, this is ocean acidification. What is happening here? Temperature, oh sorry, the pH is higher. Now the pH is lower. This means ocean is acidic, is let's say becoming more acidic. Now when the ocean is becoming more acidic, what is going to happen? We are going to see formation of more carbonic acid and reduction of carbonate ions. Carbonate ions are the ones which are very useful, okay, for the marine calcifiers like your coral reefs. So here you have more carbonate ions, they are more helpful. Carbonate ions will reduce. If the carbonate ion reduces, this causes a problem. Okay, so reduction of carbonate ions happen, this causes problem, and ultimately ocean acidification will lead to lack of these marine organisms, again a dangerous sign. Then in the oceans we also see something known as increased marine heat waves. Okay, increased, we have written this in the previous one. Okay, but here also we'll write so that all these things we remember. Increased of marine heat waves. Normal heat waves you are seeing on the land, but on the oceans there is increased marine heat waves. Okay, now again if you have to basically say what this is, again let's say this is the ambient temperature of ocean. If for 5 consecutive days the temperature is greater by 3 to 4 or even 5 degrees Celsius, okay, this is the ambient temperature, this is the new temperature. For 5 consecutive days, if the temperature is high, you call that as marine heat waves. Okay, and now what we are seeing, these heat waves are increasing in both frequency as well as intensity. Okay, 10 times more intensity compared to pre-industrial times. 50% increase has happened in the last 10 years. Now what can happen because of that? It leads to extreme weather events, storms, hurricanes. Already we've seen this point. Okay, it can lead to acidification, fine. It can lead to deoxygenation, yes. It can lead to habitat loss and biodiversity, yes, of course it can. It can lead to economic loss, fisheries, tourism, aquaculture, yes. So now these, for example, what is the consequence of, and you can even add coastal communities. Okay, in this you can even add the people being affected by this. Okay, so now you also have a way of writing more points. Okay, so what is happening? These are extended periods of regional ocean warming, and because of that these are dangerous. Okay, kelp forest, we just saw that these are kelp forest and they are overall under threat because of climate change. So climate change can lead to decline of underwater forest, and if this happens, what will happen? This will lead to again more issues, right? More destruction of the ecosystem around, more loss of species, biodiversity. So this is again going to happen. Impact on agriculture we have already seen. Okay, now again same thing, whatever I have said in a visual format. You have oceans, you have land. Okay, on oceans what you can have? Sea level rise, you can have tropical cyclones. Remember tropical cyclones, you can have storms, you can have floods, you can have ocean acidification. Okay, talking of floods, I will give you one more example here. For example, Libya was in news because of floods. Okay, and here a term known as medicanes appeared. You might have read about this in your prelims. Medicanes are again these tropical storm originating in Mediterranean Sea. Ocean acidification, we have spoken about it. Okay, on land Glacial retreat, we've already seen heat waves, yes. In oceans, we've also seen marine heat waves. Okay, land and forest degradation, forest also seen. We've seen desertification, drought, okay, loss of biodiversity, increasing temperatures for sure, yes. And we also know now the facts related to it. Carbon dioxide, remember, methane increasing, okay, IPCC's report. So now this will make very easy sense to you. And easily from now, I expect you to write down at least 10 points if they ask you, not only on the impact, but also on the consequences. And with examples, I'm pretty sure you'll be able to write the points. Okay. So talking about this, of course, then we can also talk about what is the impact on vulnerable sections. Okay. Talking of vulnerable sections, you can again think about impact on women and children. Okay. And of course, overall, in general, vulnerable sections, the points are going to be more or less similar. But again, we should be able to know that what are going to be the impacts of this. Okay. Now, for example, see, one by one, we'll see. The women are, for example, especially the pregnant women, are more prone to some of the diseases or nutritional issues. Okay. So here also, if there is a heat wave, okay, if there are heat waves, so they are more under threat. Similarly, children are also very much prone to heat waves. Okay, so this can lead to health related heat strokes, illnesses for both of them. That is also a problem. Okay, that is one. Then water scarcity is again a problem for both. Water scarcity can happen, leading to other issues, right? So water scarcity can happen in many of these countries. This is something we know. Same, if there is issue in agriculture, especially food insecurity, the availability of nutritious and availability of food will be a challenge for both women and children. This is again going to be a direct consequence here. For children, you can even add the shortage of food, etc., can also hamper their educational outcomes. For example, one. Second, if there is too much of heat waves, the parents would also not send the children sometimes for a period of time, thinking that they may be under stress. So their education can be impacted, their health already can be impacted because of lack of food, lack of water, and even heat waves. Again, all these points are directly linked. And this can also lead to other, for example, psychological issues. And by the way, think of people, let's say, again, in Africa, where there's again acute water shortage, acute food shortage. Okay. This is where a lot of violence also happen. Gender-based violence also happens in these regions. Ethnic conflicts can also happen. So one problem, already when the resources are less, climate change putting more stress on the resources, it can lead to even more issues. Okay. Specifically for women, I can say their domestic workload can increase. Okay, again, in many traditional societies, we can see that because of scarcity, because of climate change, their number one, employment, their education can also be limited. Because of that, again, more burden can happen. Same issues can also happen with children. You can think of more exploitative activities. Okay, you can also think about child labor because of lack of avenues, because of climate change. We can even extend this point. Okay. Other than that, both of them can face more respiratory issues because of both climate change and pollution, pollen grains, etc. in the air, more aerosols, all these greenhouse gases and particles. This can also lead to more respiratory problems for both. Okay, this also can be a problem here, right? Other than that, I think waterborne diseases like cholera are seen in general. Okay, this is one. Now talking about vulnerable sections in general. Okay, in the vulnerable sections, please remember, first of all, whenever I say vulnerable sections, the impact of climate change is always going to be disproportionate. Impact of climate change is disproportionate, which means the haves, the people who have resources, will be able to withstand, whereas the have nots will not be able to. This is always a tussle. Okay, and then when you put this in context, for example, vulnerable sections, what? They can be small island developing states. Their impact, of course, is disproportionate. Okay, so not, it is not just only poverty. So one is this, second is poverty. Because of poverty, the people cannot invest into a lot of disaster resilient infrastructure. So they are most under the most threat of getting submerged or facing a lot of issues. Okay, so again remember SDG 1 and disaster management again linked to climate change. Okay, right, and here also when I say vulnerable sections, you can even add the points from women and children as well. The access to food, health, all of this going to be again impacted, and all of this will lead to what? See, if there is more of these problems, women and children will face higher IMR, MMR. Same can be here. There can be higher mortality seen in the vulnerable communities. Okay, higher mortality overall. There can also be a lot of economic inequality which we see. Okay, related to poverty. This is why the access to housing, access to infrastructure is also compromised. Okay, so again, these are certain points that we can think about. So both women, children, or vulnerable communities in general as a whole, you can think about the lot of impacts that happen here. Okay, now in the coming slide, we'll also see something known as carbon inequality. Carbon inequality will lead to these issues. Okay, it is not the problem of these sections, but the problem of rich countries, the lifestyle of rich countries and rich people, which are responsible for the plight of these sections. And this again is an important topic of climate change. Okay, so we'll also see that. Fine. So I hope till now the basic sections you are able to understand. Let me just go to the framework. Then I'll go back to what we were discussing overall, right? So I hope what you are clear with, what you're clear with evidences, you're clear with the causes, both natural, man-made. You've seen impact and the consequences in a lot of detail. Fine. And even the most specific points we have seen. Now we'll move to the part of the current affairs update. Okay, so till 1, 2, 3, 4 we've seen. Now we move to the current affairs part of it. Okay, the current developments, which can itself become a mains question. So that is also something that one has to keep in mind. Okay, the very first update that one should remember is why was 2023 the warmest year ever. Okay, throughout my lecture I have referenced this many a times that 2023 was the warmest year ever. Okay, now the question remains to us, why was this? Okay, why this was the warmest year ever? This is what we have to answer. Fine. Now a couple of points will, now you will find this very easy to answer. At least one, the greenhouse gas emissions were record high. Already we have seen the graphs, very high greenhouse gas emissions. So if I talk about carbon dioxide, very high. If I talk about methane, very high concentrations. If the carbon dioxide concentration or if the greenhouse gas concentration is increasing, what will happen? This will lead to global warming, and this also contributes to higher temperatures. So both they were, we seen almost a record, okay, increasing greenhouse gas emissions. Okay, then the ocean heat budget, etc., was also, for example, very high. Ocean, all the open waters in the ocean, they absorb a lot of heat. Okay, now in this particular year we had also seen they absorb almost, they have the highest ocean heat content. Okay, so high amount of heat being absorbed by the oceans. Okay, if they are absorbing this heat, what this will lead to? Number one, of course, the sea temperatures will be warm, and overall the global temperatures will be high. Okay, this is again a trend that we are seeing that is happening. Other than that, this was a El Nino year. Okay, the second half of 2023, and of course we'll also see that in 2024, El Nino year. Okay, this leads to warming of the waters in the Pacific, and this again leads to overall warming. Okay, so El Nino year is a very important part that you should not miss out as an update, because this is an El Nino year. This is leading to more of the warming overall. Okay. Then now in 2019, IMO, International Maritime Organization, had introduced low sulfur fuels. Low sulfur fuels for ships, for commercial shipping, it was made mandatory to have low sulfur fuel. Okay, IMO is International Maritime Organization. Now, because of that, if the ship will have less aerosol emissions, what will aerosols do? Aerosols, they have high reflectivity. For this, I'll use the term albedo. This is the incoming sunlight, it is reflected. Earlier, a lot of aerosols were produced because of high sulfur content. If there is too much of aerosols, a lot of the incoming sunlight was getting reflected. Now, because of ban of this and use of low sulfur fuel, lesser aerosols means more of the incoming sunlight is able to reach. And if more sunlight is able to reach, less is reflected. What will happen? The temperature is also getting increased. This is also seen. Okay. Then we are also seeing this as a long-term pattern. It is not a one-off pattern that only this year is warm. The decade previous to this was 2011 to 2020 was warm. Okay. Similarly, there's a long-term pattern in the warming that we are seeing. So again, this is not something as an aberration. Okay. So we are seeing overall, there was a warmest year on record and the human activities are persistent. Okay, human activities are persistent overall. So this again continues this as the warmest year. And again, in addition to that, we can also say more of extreme weather events are happening, which also again leads to more warming. So again, a feedback loop is also formed. Fine. More extreme weather events leading to more of the warming and more of the warming leading to more extreme weather events. Fine. So what is the takeaway? Why this was the most warmest year? Main record increase in greenhouse gas emissions as seen from the data as well. And whenever you now write, just quote either IPCC or WMO. Okay, the ocean heat content also increasing substantially because again there is so much of CO2 available. The oceans will absorb CO2. Okay, leading to ocean acidification, more heat getting trapped. It was El Nino year. This is one fact you cannot miss. Your answer is incomplete without this. Lesser aerosols available, which leads to more of heat. Okay, long-term heating pattern is seen because of persistent human activities and overall increase in extreme weather events. Okay, this is why you see a huge increase of temperature. Okay, then another term is something you should know: Arctic amplification. Okay, for keywords like this, just have a very small, simple framework. What it is, you should be able to define this in 1 or 2 lines. Okay, what this is, then of course how it happens, and then of course what will be the consequences. If you want to break this down even further, you can break this down into short term, long term, but this should be the approach overall. Okay, what, how, consequences. So what is Arctic amplification? That Arctic area is warming twice as fast as compared to the global average. Okay, so whatever is the rate of heating or the warming in the global ecosystem, the Arctic region is almost heating twice that. Okay, so I'm just writing 2x, you can remember. This is also known as polar amplification or polar Arctic amplification. Okay, that especially in the polar regions, there is a huge increase in the warming, almost twice as that of the overall average. Okay, now how is this happening? Or let's say, of course, why? Both these things, right? Here, the first major component is ice albedo feedback. Okay, ice albedo feedback, very easy to remember. I'll just show you one simple infographic. Okay, now you have a ship. From the ship there is an emission of pollutants. There is also black carbon. Now this black carbon is depositing on this white ice sheet. Now remember, whenever a surface is white, for example for ice, it will have high albedo. ice will have high albedo, which means ice will reflect whatever, almost everything, almost 90% albedo is there for ice. It will reflect, whereas for something black, it will absorb. So if the black particles will deposit on this ice like this, what will happen? It will absorb heat, and then because of absorption of heat, the ice will begin to melt. The moment ice melts, beneath ice there is water. Water versus ice, which is darker? Water is darker, ice white, very much light. So now exposed water will absorb more heat. Okay, if it absorbs more heat, the surrounding ice will melt more. Okay, again more area is exposed, it will again absorb more heat, more ice will melt, and again a feedback loop is there. Okay, so what happens? Pollutants from the ships, especially black carbon, depositing on the ice. Okay, because of this, the ocean surface is exposed. Ocean surface is darker than the ice. It absorbs more heat. Ocean absorbs more heat. If oceans absorb more heat, more of this ice is going to melt. And this is going to lead to a proper climate crisis. Okay, so again, this is something that we can understand. So the first thing to remember here is there is the ice albedo feedback in functioning. And if possible, if you are able to, don't have to make this very detailed, but a small loop you can make. Okay, so what you can do, what I've already explained to you, you can just create something like a cycle. Okay, so you can mention black carbon from ships. Okay, leading to heating of ice. Ice melts. Okay, ocean exposed. Ocean heats. Then again, of course, what happens? Ice melts, more black carbon. All this cycle keeps on happening again and again. A very simple diagram to explain what is the ice feedback or ice albedo feedback. Fine. This is the main reason why Arctic amplification is happening. Okay. However, for example, this is Earth. This is the tropic. There is the pole. If the tropic is getting heated, this heated water will again go back to the poles. Okay, so heated water going back to the poles. So both one ocean currents, so warm ocean currents, they are going towards the pole. So Arctic is getting heated. Similarly, atmospheric circulation. Okay, so again winds which are warmer, they are also going towards the pole. So both atmospheric wind circulation and also water circulation, both of them are going, which means more heat is going towards the Arctic region. More heat going towards the Arctic region, that is one. Next, what we had seen just now was black carbon emitting from ships, and we can also say more greenhouse gases emitting. Okay, so one is black carbon, but of course there is more greenhouse gases. What will greenhouse gas do? There's a lot of commercial farming, there's a lot of commercial shipping in the region. These greenhouse gases are going to lead to increase of temperature in the Arctic region. Increase of temperature, fine. So greenhouse gases concentration in general is increasing throughout the world, but of course it is also increasing in the Arctic region. So this also is a challenge one needs to overcome. Okay, this is there. Other than that, because of warming in the region, there is higher cloud cover. The warming in the region leads to higher cloud cover. If there is higher cloud cover, the warmed part is not going to escape, it is going to be here itself. So it is the presence of the cloud cover which also leads to more warming. Okay, so cloud cover can trap more heat. If it traps more heat, more of the heating will happen. Okay, and last thing is more water vapor. As the Arctic is getting heated, okay, warming of the Arctic leads to higher evaporation. Higher evaporation means, evaporation is what? You will have more water vapor. Water vapor is a natural greenhouse gas. So when I say greenhouse gases, one, man-made greenhouse gases are increasing, and even the natural greenhouse gases is increasing. This all is contributing to higher temperature in the Arctic, contributing to polar Arctic amplification or Arctic amplification, as simple as that. Okay, so water vapor, cloud cover, trapping heat, man-made greenhouse gases, ocean circulations, and even the atmospheric circulations, and ice albedo feedback. Out of this, the most prominent is this. You should not miss out. But again, if you get a question, what is Arctic amplification? First, define what it is, tell how is it happening, and also tell what are the consequences, if possible, if time and space permit. Mention both short-term consequences as well as long-term consequences for the region. Okay, both short-term as well as long-term. Right now, here again, just few points that for us to brainstorm. Okay, or perhaps I'll just use another slide here. Okay, so we are writing about the short term as well as the long term. Okay, now one of course is there is going to be increase in the ice melt. Okay, the ice melt in the Arctic region is definitely increasing. Okay, and if this is melting, direct impact will happen on, let's say, polar bears. So the communities or the population dependent directly on it, because this is going to be directly impacted. Okay, so habitat loss for seals, polar bears can happen. This is the direct consequence of short term ice melt. Okay, so one is this. Second is there is going to be a rise in the sea level because of this melt. Okay, sea level rise is happening. Why? Because of decline of sea ice. Sea ice overall is going to decline. This is going to be one of the things that can happen. Now, this can also trigger extreme weather events, because this can lead to changes in precipitation. Okay, again, changes in cloud cover formation. This can ultimately trigger more extreme weather events. Then, if Arctic amplification is happening, permafrost will also melt. We've already discussed melting of permafrost can release methane, carbon dioxides. It can also release the trapped bacteria, the trapped diseases, etc. That can also be released. Then the communities. So coastal communities, number one, will be impacted because of the increased sea level rise. There can be coastal flooding. Flooding can also lead to coastal erosion. Okay, this will be very small in the short term, but this will be very pronounced in the long term. Okay, other than that, communities can also, the communities which are going to be present here, okay, in the coastal region, they will face issues in resource extraction. Okay, resource extraction will be a challenge, and again the movement of ships, etc., the navigation might also be impacted in the short term. Okay, navigation, etc., can be impacted here in the short term. Fine. Now, in the long term, what will happen? All the things I've discussed, they will become more pronounced. Okay, so while I was only talking about a small sea level rise, in the long term, this sea level rise will be a big component. And if the sea level rise is going to happen, this is going to threaten the small island developing states. Okay, other than that, ocean as well as atmospheric circulation will totally change, because earlier the ice cover would have dictated a lot of how cloud formation will happen. Now ocean and atmospheric circulation will change, which can lead to long-term changes in the ecosystem, availability of species, and already we will see lot of loss of biodiversity would happen here. Okay, so these are some of the major reasons that one has to keep in mind. Again, linked to this is something known as AMOC, which I'll just tell you in some moments. Atlantic Meridional Ocean Circulation. Okay, I'll just tell you. This also can be a long-term change. Weakening of AMOC can happen. We'll see how this can happen. Okay, so these are few things that to keep in mind. Yes, but see, the examiner is going to be impressed if you bifurcate and segregate it and present the information in the most organized manner. That is what we have been discussing so far. Keep it as organized, as logical as possible. Fine. Short term, long term, what can happen? Okay. So again, going back, so this is what we had seen. Consequences, how, okay. This is what is the basic part we've seen. Now, talking of the Arctic amplification and glaciers, there's also one small development that I have to tell you. Okay, that is also known as the Karakoram anomaly. So, while we are discussing the glaciers in general, we have seen glaciers throughout the world are melting. Okay, but what is happening here? So, one you should know, in the Karakoram region, there is going to be a retreat. Okay, in the Karakoram region, we are going to see a different trend here, right? Instead of the glaciers melting, we are seeing the rise of glaciers. Okay, the growth of glaciers melting in the Karakoram region. Okay, so one you should know, the Hindu Kush, Western Himalayas, Eastern Himalayas, and then this Karakoram region. Okay, so here in the Karakoram part, what we will need, what we just need to know, two things. Okay, for glaciers, number one, there is just one thing that you need to know. Okay, in Karakoram, so one, it is the outlier. So you'll have to just explain what is happening throughout the world, that the glaciers are retreating. Okay, but in the Karakoram region, what is happening? The glaciers are increasing in size. Now, of course, the very obvious question will be, why is this happening? Okay, so again, a very simple explanation. Two things you should know here. For why, number one, this region happens to be present in a subduction zone, which means, of course, the region is tectonically active. Okay, and because of that, there is again a lot of tectonic shifts and activity happening. And second is because of western disturbances. Again, these two things you read in more detail in your geography part, but again, just for the sake, because we are seeing glaciers, so for a holistic coverage, one, what is Karakoram anomaly? That overall in the world we are seeing increase in the glaciers, or there is higher glaciers present in Karakoram region as compared to the world. And why is this happening? Because of two main reasons. This region is in a subduction zone, number one, and second, there is more of the western disturbances in the region, which leads to, these western disturbances ultimately lead to higher precipitation, leading to more snowfall. So which is why instead of receding, there is more snowfall in the region. Okay, so this is also one thing to keep in mind. All right, then there is something known as tipping points. Okay, so here also this as a concept. So again, what is the framework for you to know? What are tipping points? Number one. Okay, again we'll see what are these tipping points. So again, what are tipping points? From the mains, just one or two line definition, that these are the ecosystems of the world who again have a lot of biodiversity. They are very important, but because of climate change, if we are not, or let's say if we are pushing them beyond their threshold boundaries, okay, we already know that temperature increase is happening at a very rapid rate. If we are not able to control this threshold increase, the changes that can happen in these ecosystems or the tipping points can be irreversible and permanent. Okay, so these tipping points, number one, very important for the biodiversity. And if we are not able to restrict or halt the temperature increase to a threshold, we might see them collapse. Okay, so this again is something that is important, that there is a risk of losing them if climate change is not tackled, if the things are not taken care of. Okay, so that is one thing we will remember. Okay, they may experience irreversible changes and they can ultimately collapse. Again, what are these regions? These are the regions that we have just seen for land as well as oceans. They can include forests, they can include coral reefs, they can have different ocean circulations, it can even have ice sheets, icebergs, etc. Right? All these regions can be a part of your ocean ecosystems, even including the coral reefs. Okay, tundra forests, tropical, Arctic, Antarctic, all of these are the tipping points of the earth. And the main thing or the main takeaway for us is that we have to ensure that this does not gets damaged beyond repair. Okay. Now, in this regard, there is something, if you see here, Atlantic Deep Water Formation, also known as AMOC, Atlantic Meridional Ocean Circulation. Fine. This is also what I had just briefly mentioned in the point, okay, in the previous point related to Arctic amplification. In the long term consequences, we had seen that. Now, let us understand this in the very simple manner. There is a term that is known as thermohaline circulations. Thermohaline circulation. Thermo means temperature, haline means salinity, salt content. Okay, so because of changes in temperature and salt content, the oceans, they move, and this whole thing is known as the global conveyor belt. Okay, so for example, that red marked part is of course the warmer current, the bluer one is the colder current. The tropics will have the highest heating. So from the tropics, the warm ocean currents will move towards the poles. In the poles, they get colder because of these ice sheets present. Okay, and then of course they are heavier, so they will submerge, and this whole circulation will happen. Okay, so right from the Atlantic to the Indian Oceans to different parts of the world. So number one, these thermohaline circulations affect the entire world. Okay, it is not limited only to one ecosystem. One. Okay, now what is happening because of climate change? We've already seen ice sheets and glaciers receding. So this is the Greenland ice sheet. Okay, so of course this is melting. If the ice sheet is melting, the warm water which is here, you also have the North Atlantic drift. So traditionally what was happening, this warm ocean current used to have a very sobering influence on the Europe. In the Europe was earlier getting frozen. Okay, now because of this warm current, Europe and especially the ships moving in this region could have moved, could have properly navigated. Okay, so this again was very important, especially in the winters of the Europe. So one, it helped Europe become warm. Second, it helped in the movement of ships. And third, it had an impact on the global ecosystem. How ocean currents move, how winds pattern, how rain, all of that is going to be impacted by this. Now, bring into picture climate change. Faster receding of Greenland ice sheet is happening. So this warmer current is becoming increasingly cold. Okay, so number one, this ocean circulation, okay, which was, let's say, moving at whatever pace it was, it is going to weaken. This ocean circulation will weaken because of increasing inputs from this ice sheets. And if this is going to weaken, there will be the opposite impact on Europe. So first impact will be Europe will now be colder. Earlier Europe used to get warmer in the cold, in the, let's say, winters. Now because this AMOC is getting weak, number one, Europe is getting more colder. That's the first consequence. And second, all the regions of the world, be it the formation of monsoons, El Nino, drought, desert, all the regions will also be impacted. So the takeaway for us is, what is AMOC? We know. But what is happening because of climate change is that AMOC is becoming weaker and weaker. And because of that, number one, regionally, it is going to directly impact Europe because Europe is now going to become more colder. And the second thing is, of course, this is going to lead to a lot of other issues globally as well. Okay. So again, major takeaways: Europe will face colder weather conditions. Number one. Okay. Then the northern hemisphere will be far cooler, which also means the movement of ships can also be impacted here. It can also impact El Nino. It can also change the monsoon patterns in the region. Okay, potentially leading to more drought, and drought can also be linked to food security, water security, all these getting impacted also as well. Okay, so this is also something related to. So again, please remember, IPCC highlighting that AMOC is losing the stability and likely to decline in the 21st century. Okay, it is likely to decline in the 21st century. All right. Then there is something known as carbon inequality. Okay, so here a very, let's say, popular report by Oxfam. Okay, so just this basic thing we'll understand, that if you see, this is the richest 1%. The richest 1% are responsible for 50% carbon emissions of the poorest 50. Okay, this carbon inequality is actually at the crux of the negotiations of climate change, that we see the rich and the developed nations responsible for the current state of flux. Okay, and the richest 10% are responsible for rest of the world's emissions. Okay, so richest 1%, poorest 50. Again, these kind of impactful diagrams you can definitely draw in your mains answers. Okay. Okay, so again, richest 10% contributing to 49%, okay, of the total lifestyle emissions, whereas the poorest 50% contributing to barely 10% of the world's emissions. So if we understand this, this is why the whole debate in different climate negotiations happen. The developing countries demanding the developed nations to pay for, okay, so what they've done. So the report is Confronting Carbon Inequality. The report is by Oxfam. Even if you write down, the recent report of Oxfam highlights widespread and rampant carbon inequality. That is going to be fine, and you can even mention one of these facts. I'm telling you three facts. One, richest 10%, and richest 10% and their lifestyle emissions. Whatever you are able to understand easily is what you should ultimately go ahead with. All right. Okay, and again we remember why there is a cause of carbon inequality. Okay, the causes are, number one, it is very clear the rich pollute more. Okay, more industrialization, more needs, more pollution. Okay, the burden of climate change overwhelmingly falls on these population. Okay, this is what we've seen, the burden of climate change falling on the rich nations. They are the ones doing the pollution, but the burden falls on the poor as well. What can they do? They have very limited contribution. Okay, there is a skewed access to resources. Most of the resources available with the richer nations, they are the ones polluting. This again is a problem. And ultimately lifestyle issues. Okay, be it energy expenditure, be it the carbon footprint, in all of these regions we see the widespread carbon inequality happening overall. Okay, so this is again one thing to see. And what is the impact? Again, we have seen all these dimensions. Okay, so again, just a quick recap for you. Social impact on women, vulnerable, there are health hazards, it burdens the poor, of course. Okay, now the poor as an individual and again as a nation, the poorer nations have very limited capacity. They don't have access to resources, they don't have access to technology. They are the ones who are forced to transition to new resources. How can they transition without the access to capital? How can they transfer without the access to proper finances? Will be very difficult. There is a huge economic impact of the carbon inequality. Okay, which means there can be more disasters. The poorer nations will find it difficult to recover. Okay, there is unequal growth. There is again economic instability. Okay, and again because of more of climate change, the people will have reduced demographic strength. Think about India right now. We face severe heat waves. In heat waves, the people who are working outside, their capacity to work is reduced. Okay, so they are not able to work as much. Reduced demographic strength. They can have health issues, more out of pocket expenditure, again a problem, right? Similarly, the poorer nations, they will have very reduced bargaining power. This is also seen globally. Policies as well. By policy, again, I mean, for example, the developing nations, they still require coal. They cannot transition immediately because the transition also requires money. It is expensive. And this again is leading to carbon inequality. Okay, so again, you will find this is again a complicated topic overall. Okay, that one, developed nations have emitted as much as they wanted and they're continuing to do so. But now they're saying that everybody should be responsible and they should cut down the emissions, but they are the ones who are not leading from the front. This is something we also explore more in the next lecture when I talk to you about the climate change conventions and what are the sticking points. Okay. Another term that you perhaps would have seen in prelims, tropicalization, in your current affairs. Again, you can link it to your answers in mains just as a one word. Now, what is happening because of climate change? You are seeing, for example, this is Earth, this is the tropic. The species from the tropics moving towards the poles. This is again a part of migration. So, one, we have seen migration of people, but migration is also seen in species. This is known as tropicalization. There is also something known as borealization, which means in the temperate regions, because tropic is getting warmer, temperate is also getting warmer, the species are here also going to poles. So both tropicalization and borealization is happening. This is the movement of the species. Okay, this is the movement of the species that is happening. All right. And this is what we had seen, climate refugees from various things. Tuvalu Islands, Kiribati, again countries like Maldives. We also know Indonesia, which had recently changed its capital because of climate change. And not just this, more countries coming to the fore, especially with the issue of small island developing states overall. They are more and more getting threatened because of climate change. Okay. Now, remember, I have already, so this is again just the final summary. What we had seen, we have already seen the consequences of climate change, all the dimensions: environmental, economic, social, political, cultural, technological, right? So, all the dimensions that we have seen overall, you can just club them one by one. Okay. So, you can just have it in one go and you can write it down. So, now there's again a chance for you to recap all what we have done. Okay. So this is what we had actually done in these previous parts, if you remember. Yeah, these dimensions one by one. Okay. But here also my point is not to cram. If you understand it organically, if you spend some time on it, you will be able to generate the points automatically. That is again the main focus of the course. Not to spoon feed you, but ultimately help you enable to write down points as and where possible. And with that, we come to the end of this lecture. So here we finally see you have previous year questions. Okay, these are the kind of questions asked on this topic. Okay, you can have a look at it one by one. If you want, you can also attempt it. Fine. So this also will give you a great understanding. And again, based on what we have discussed, I'm pretty confident you will be able to write down a lot of points overall. Okay, so you are more than welcome to write questions here, and you can also refer the mains the PYQ book of Sunya. And for these questions also a lot of content you can also see and you can also understand. But again, from what we've discussed, I'm pretty sure you'll be able to write decent answers, right? So with that said, we will now meet in the next lecture where we'll be talking about things like National Action Plan on Climate Change, okay, India's Panchamrit, and also of course the very important update of COP28, okay. So I hope you're able to connect, and again I'll just go back to the final part here, just a second. So this is where we started the lecture with. This is going to be, okay, so we had seen what? We had seen the facts and the evidences, we had seen the causes, we'd also seen the impacts and the consequences, initiatives, and the COP28 part we'll now see in the lecture number 2. But again, what is your job now? Whatever points we have tried to brainstorm, if you have made running notes, excellent. If you have not, again go back and see, but try to organically connect and link, okay? If you're able to do so, again, next assignment will be to practice the previous year questions, and then I'll meet you in the next lecture with another set of updates. Okay. So with this, I'll meet you in the next one. Thank you.